Also share my content screen. Stop broadcast. So what was the questions in the so what was the first question? I mean, let's look at question 6. Or maybe let's do question 5. Okay. So question 5 of the homework. It says that derive an equation for angular velocity. So angular velocity in terms of linear velocity. Omega in terms of V. So omega is the angular velocity and omega is the linear velocity. So we know that, what we know? We know that omega is equal to 2 pi times f, the frequency. That means the number of f is the frequency, the number of cycle. That means the number of cycles per second, for example. Right? Okay. So if the velocity is v and you have an angular movement, angular rotation, that means what is the frequency? So f, what is the frequency in terms of v? F is equal to v divided by 2 pi r, right? Because 2 pi r is the distance for one cycle. 2 pi r is the distance for one cycle. Now, if you divide the linear velocity, that means distance per second, by the distance for one cycle, you get what? You get the number of cycles per second, right? Or you can look at this equation. This is the same thing as saying that, I mean, this is equivalent to saying that V is equal to 2 pi r times f. Because 2 pi r is the distance of one cycle. And if you have the frequency, so the number of cycles per second, if you multiply it by 2 pi r, you get what? You get the distance per second, right? Which is velocity. And we know that omega is equal to 2 pi times f is equal to 2 times v over 2 pi r is equal to v over r. So it gives us the angular velocity in terms of linear velocity. This is the formula. Now we can use basically this equation for doing question 6. I mean, you don't have used this equation, but it's useful and it makes sense. So what is question 6? Tell me. What is question 6?
Car travels at a constant speed of 100 per hour.
So the speed of the car, that's the linear speed. The linear speed of the car, v, speed of the car, is equal to 150 kilometers per hour around a circular track of radius. What is the radius? What is the radius of the track?
300.
300 what? Meter, kilometer, meter. So it's like this. And there is a car here. And the radius is, yes, radius 300 meters. So we saw that in the previous question, the relation between angular velocity and linear velocity is that omega. So this is usually called omega. This is a letter, Greek letter. So omega is v divided by r is equal, because we are. So you have to decide, you want to write the units in terms of kilometer or meter. So let's do the kilometer, okay? So it's 150 and then divided by 300 is what? How many kilometers? 300 meters is equal to 0.03. No, just 0.3. 0.3. Okay. So this is equal to what? What is 5,000 or 500? Because you have to multiply by 10. So it's 500. So what is the unit? Radian per, is it second or hour or minute?
Hour.
Per hour. Okay. Okay. So is that clear?
Yes.
So another formula for angular, this is the formula for angular moment, angular velocity in terms of the frequency. Okay, you can also write angular velocity in terms of in another formula in terms of the change in the theta. So that's, I will call the delta theta divided by delta t. That means how much the angle changes, the rate of change of the angle, basically. Because delta theta divided by delta t is the rate of change of the angle in terms of time, per time. So the next question, it says that find the angular velocity of Earth rotation. So you can use this formula for question 7. So for question 7, what is the change of angle when Earth rotates in 1 day, in 24 hours? 24 hours, Earth does just one cycle, right? So it rotates one cycle. That means what is the angle? One cycle is 2 pi. So you can use this formula, say omega is equal to delta theta divided by delta t. But the change in angle is just 2 pi in what time? So it rotates 2 pi in 24 hours. So it's equal to pi over 12. So you have to be careful about the units. Here is radian per hour. Or, no, per hour. Per day would be just 2 pi. 2 pi over 1 day. But here we are writing in terms of hours. That's why I put 24. That's omega. So it's pi over 12 radian per hour. So the interesting question, which is question next one, is to find the linear speed of the surface of the Earth. This is the angular velocity. What is the linear velocity? So we know the relation between angular velocity and linear velocity. We obtain it here. So we know that omega is equal to V divided by R, or you can say that V is equal to omega times R. So if you want to use this, so the linear velocity of the surface of the Earth is omega times the radius of the Earth. What is the radius of the Earth? What is the radius of the Earth? It's given in the question. So V is equal to pi over 12 times 6,371. So can you divide 371 by 12? So let me do this. 6,371 divided by 12.
31. 131.
Sorry. And you multiply it by pi. So let me do it. So 6,371 times, so let's say 3.14 divided by 12 is something about 1,667. And the units are kilometer per hour. That's the speed of the Earth that we experience just right now. Can you believe it? 1,000 kilometers per hour.
No question. If you like driving a plane that's faster than this speed, then what happened?
Drive it.
Yeah, like if you now is the speed of the Earth, right?
Yeah.
Now if we hop on a plane and we go faster than this, what happened?
So you can basically, it depends. If you rotate in the same direction of the Earth, you just move with Earth.
Well, I move faster than.
Oh, you move faster, so you go faster.
What happened then?
So it depends if you go
What can I
in the
see?
opposite direction or.
Let's say opposite. What can I see? Okay.
Huh?
What can I see if I'm faster than this one? Do I find it stationary? Or
No.
because I'm faster?
No. Yeah. But if you can go with the same velocity in the same direction, then basically it's like you don't move.
I'm faster.
Yeah. So you move faster. You go. I don't know if I understand what exactly. Anyway, so that's the velocity of the surface of the Earth. Okay. So some lessons from here is what is the meaning of the angular velocity? So you can say that it's basically the main concept or the definition is the rate of change in the angle per time in terms of time, or delta theta divided by delta t. There is another formula that describes angular velocity in terms of the frequency. It's 2 pi times the frequency. And frequency is basically the number of cycles per time. Because when you multiply the number of cycles by 2 pi, that's the change in the angle, right? Okay. So yeah, so that is so here we have 3 important formulas. So one is omega is equal to delta theta over delta t. Omega equal to 2 pi times f. F is the frequency. The number of cycles per second or per hour, depends what unit you use. And then another important formula was omega is equal to V divided by R. V is the linear velocity. Okay. Okay, guys, so let's move on. So I introduced some basic, is there any question, by the way? If there is not, so I just want to, I introduce some basic trigonometric functions like sine x and cosine x. And you know how to draw the graph. The next is to introduce tangent and cotangent. So tangent is defined by this formula. Sorry. Tangent is sine x divided by cosine of x, and cotangent is just the inverse of, 1 over tangent, which is cosine of x divided by sine of x. Okay. So now we have two new functions. One is f of x equal to tangent of x, and another is g of x equal to cotangent. But they are quite similar in the following sense. So first of all, it's important because you have a denominator here. So one question is, what is the restriction for this fraction? And in other words, what is the domain of the tangent? So cosine of x cannot be 0, right? So domain of f. So tell me, what is the domain? Can you guess? So at what point cosine is 0?
90. 90 degree. Sine is 0.
No, at what point cosine is 0?
98 0.
So cosine of x equal to 0. So that means 90 degrees. So I told you it's better now, from now on, to write everything in terms of radian. So in terms of 90 degree, we say pi over 2. So x equal to pi over 2. But there are other values at which cosine is 0. What is it? Can you tell me, Lisa?
Sorry, what? You ask for what? Sorry.
Pardon me? So at what point cosine is 0? That's the question. So one is pi half, but there are many. I mean, there are infinitely many actually. And the other, like 3 pi half, 5 pi half. You also have minus pi half. You also have minus 3 pi half, minus 5 pi half. So can you write a formula for the zeros of cosine in terms of integers? So you can say that x equal to, in general,
Oh, pi half plus k times pi, and k is
you see on the top, on the denominator, you have 1, 3, 5, 7. So it's only odd numbers. So it would be 2k plus 1 times pi half, in which k is an integer, right? Because you only have odd numbers. If k is if you have an even number on the top, then it cancels out with 2, right? So for example, you cannot have 2 pi over 2, which is just pi. Cosine of pi is minus 1, it's not 0. So it's only odd coefficient, odd multiples of pi half. It could also be negative. So that means the domain of tangent of x if I want to write here, so the domain of tangent is all real numbers except this guy. So domain of f is the set of real numbers except x cannot be 2k plus 1 times pi half for k integer. And if you want to draw the graph of tangent, so another lesson is that x equal to pi half is a vertical asymptote, because when x approaches pi half, then cosine would be 0, and then but sine is just 1, so you get 1 over 0, which is infinity. Okay, so if you want to draw the graph of tangent, so there is a vertical asymptote at pi half, and also 3 pi half. So the graph of tangent is something like this. And so on. And it's periodic. Okay. This vertical, what is this vertical asymptotes? These vertical asymptotes are x equal to pi half, x equal to 3 pi half, x equal to 5 times pi half, and all these guys, 2k plus 1 times pi half. Okay, these are the vertical asymptotes of tangent. Cotangent has the same graph, I mean, similar, not this, exactly the same, except that for cotangent, because cotangent is, if you have cotangent, which is cosine divided by sine, so what are the zeros of sine? So 0 of sine is what? X equal to pi. Oh, the first one is actually 0, pi, 2 pi, 3 pi, and all this. So in general, you can say that x equal to k times pi. So any multiple, any integer multiple of pi, k an integer, like 1, 2, 3, minus 1, minus 2, minus 3, 5, 10, all integer multiples of pi. These are all zeros of sine. So the domain for cotangent is the set of real numbers, except x cannot be k times pi, k an integer. So x equal to k pi, I mean x equal to pi, 2 pi, these are all vertical asymptotes. These are our vertical asymptotes for cotangent. Asymptotes of cotangent. So it's it's quite similar, except that the asymptotes are 0, pi, and so on. And it's yeah. So I want you to draw the graph of cotangent, okay? Can someone draw the graph of cotangent and show it to us? Do you see my screen, guys?
Yes.
So look at my screen. So by the way, these two are graphs of sine of x and sine of 4x. So you see, so the functions like sine and cosine are periodic. You can also call them oscillatory function. They oscillate. I mean, they go up and down. So you see the sine of 4x oscillates faster than sine of x. So it goes 4 times faster, I mean 4 cycle per time faster than sine. If you imagine that the x-axis is t, okay, you see, and so this is like cotangent. I want to show you. So you see, this is cotangent of x. So x equal to 0 is a vertical asymptote. X equal to pi is a vertical asymptote. X equal to negative pi is a vertical asymptote. Any integer multiple of pi is a vertical asymptote, right?
Mm-hmm.
And you can also define, there are 2 more functions that we can build from sine and cosine. One of them is 1 over sine . One of them is 1 over cosine. So 1 over cosine of theta is called secant of theta, or secant of x. So secant of x is just 1 over cosine. This is secant, it's 1 over cosine. Again, you see vertical asymptotes at the zeros of cosine. What are the zeros of cosine? Like pi half, 3 pi half, minus pi half. These are the vertical asymptotes. So secant is 1 over cosine. We can also define 1 over sine, which is called cosecant. Okay?
Mm-hmm.
Okay. Let me go back to my notes. All right. So yeah, so we have another function. I just told you f of x is equal to secant of x, which is defined to be 1 over cosine of x. So I want you, as your homework, just find the domain of this function.
Mhm.
Okay, so
Mhm.
that comes, now it comes to the trigonometric identities. You just saw some identities, which is basically the definition of tangent of and cotangent. So tangent of x is equal to sine x divided by cosine of x. And cotangent of x is equal to 1 over tangent of x. Cosine. Maybe the most important identity involving sine and cosine is this one: sine square of x plus cosine square of x equal to.
Cosine.
So you remember we talked about unit circle. If you have a unit circle, then unit circle in the like a plane, cosine of theta was just the x, sine of theta was y. I mean, here I'm using x for the theta, but you can imagine that. So sine theta plus square plus cos theta square is just x square plus y square in that picture. Maybe let me just write theta because I don't want to confuse you. So let me draw this picture that you saw before. So if this is theta and the radius is 1, so we saw that y and this is x. So we saw that by definition, cosine of theta is what? In this picture, what is cosine of theta?
Y over 1.
Is it y or?
Oh, y. Equals y.
That's sine.
Cosine. X.
Is x. X equal x over 1, yes. Which is equal to x. How about sine?
Y.
Is equal to y. So sine square plus cos square is just y square plus x square, which is equal to what? Look at this picture.
1.
1. Exactly. So that's the most important identity that you should know. So sine square theta plus cos square I theta is equal to 1. And you can write like x, it doesn't matter. So the x or theta are variables. You can say sine square of ln plus cosine square of ln is 1. If you use ln as a variable. Okay. Okay. So next, so far we have this identity, which is basically definition of tangent and cotangent, and then sine square plus cos square. So can you find 1 plus tangent square? So or maybe let me put it this way, prove that. So sometimes they want you to prove some identities, like prove that, I mean, that's a simple one. 1 plus tangent square of x is equal to
1 plus
secant square of x. So let us prove this identity, okay? So you can start from either side. So I prefer here to start from the left-hand side. 1 plus, whenever they want you to prove something, you have to go step by step and use definition or some well-known identities at each step. So here I just use the definition of tangent. So it's 1 plus sine over cosine, which is the tangent square, right? So this is equal to 1 plus sine square of x divided by cosine square of x. Now you have two fractions. If you want to add them, it's equal to what? It's equal to cosine square of x plus sine square of x divided by cosine square of x, right? So what is the top, the numerator? So,
sine square
hmm?
times
So on the top, you have cosine square plus sine square, which is equal to, I told you, the most important identity. What is sine square plus cosine square?
1.
1. So this is equal to 1 over cosine square. But 1 over cosine is just secant. That's the definition of secant. Remember?
Yeah.
Okay. So we are done. So that's one of the identities that we proved using other identities and using definitions. So maybe I give you some homework here. So this is your homework. Prove that A tangent of theta plus cotangent of theta is equal to secant of theta times cosecant of theta. This is cosecant. Cosecant is 1 over sine. Okay, I give you some more. So B, one minus sine square of x over 1 minus sine x minus 1 is equal to sine x. Please write these questions. It's your homework.
Mhm.
Like graph it.
Not graph, just prove these identities. You have to prove these identities. And by the way, I told you that this guy is cosecant C. It is equal to 1 over sine of theta. That's the definition. And secant of theta, we just saw that it's 1 over cosine. So when I put 2 points like this equal, that means that is the definition of something. Okay, and part D, cosine of x over 1 plus sine x is equal to secant of x minus tangent of x. Okay?
Mhm.
So prove these identities. Okay, that's your homework. What?
No, it's answered.
Okay, so no, just you don't have to do it now, but you have to do it today. And please hand in your homework tomorrow. Okay? Okay, so let me go to the next topic, which is sum and difference. Identities. So basically, so now the question is, if you have two angles like AB, what is sine of A plus B? This is not equal to sine A plus sine B. But sine A plus B is equal to sine A times cosine of B plus sine B times cosine of A. So that's the first sum of two, sine of sum of two angles. So what about sine of A minus B? Can anybody tell me what is sine of A minus B? You can just use the first identity, sine of A plus B. Instead of B, you have minus B. Can you tell me, Lisa?
I think just change the plus to minor.
Yeah, exactly. So it's sine A times cosine of minus B plus sine of minus B times cosine of A, which is equal, but cosine is even.
Mm.
So cosine of minus B is cosine of B. But sine is odd. Sine of minus b is minus sine b. So sine of a minus b, that means sine of a minus b is equal to sine a cos b minus sine b cos a. That is for sine. How about cosine? Cosine of a plus b, the formula is that this is equal to cosine of a times cosine of b minus sine of a times sine of b. So you can do the same trick for cosine if you want. Oh, sorry. If you want to find cosine of a minus b. So this is equal to cosine of a times cosine of minus b minus sine of a times sine of minus b. So that is equal to what? Cos a cos b. Now because sine of minus b is minus sine b, so that would be plus sine a sine b. So cosine of a minus b is cosine of a cosine of b plus sine a sine. So you got these identities. One is for sine, and then sine of difference, sine of the sine sum, sine of the difference, cosine of the sum, and the cosine of difference. So, and you have to memorize these identities, sine of and cosine of sum and difference. So now the one question that one might ask is that, so compute cosine of pi over 12. Can you compute cosine of pi over 12? And sine of pi over 12. So that's the question. Please try to answer this question. Compute cosine of pi over 12 and sine of pi over 12 using these identities. You have to use difference. So first try to write pi over 12 pi over 12 is pi over 3 plus or minus. So 1 over 12 is 1 over 3 minus 1 over 4. So that means cosine of pi over 12 is equal to cosine of pi over 3 minus pi over 4. Which is equal to what? Cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. What is cosine of pi over 3? Anyone remembers cosine of pi over 3? You should know these things by heart.
1 over 2.
1 over 2. Cosine of pi over 4.
1 over root 2.
1 over root 2. Plus sine of pi over 3.
Root 3 over 2.
Yeah. Times,
Also 1 over root 2.
yes. So this is equal to 1 over 2 root 2 plus root 3 over 2. Okay? I leave the sine of pi over 12, compute sine of pi over 12 yourself. And another homework I want to give you is try to find a formula for tangent of a plus b. So when I say a formula for tangent of a plus b, that means tangent of a plus b in terms of tangent of a and tangent of b. So use the cosine and sine identities and try to find a formula for tangent, okay? That's your homework. Okay, guys, any questions?